All right, hello everyone. Welcome to our next kind of open source investment research roundtable discussion. Matt and I are kind of putting on here, and this time we have the pleasure of having Jordan from TheLimitingFactor. Many of you may know him, sort of a battery specialist, all things battery related with regards to Tesla. He's a go-to for that, and he's got a great channel to follow and support if you can. And then Josh Phillips, who goes by the, I think, Twitter handle Josh is Blonde. He's got a lot of, interesting takes on the mining and also battery chemistry and such. So, yeah, welcome to the show, Josh and Jordan, and we'd love to have you. How's it going?
Yeah, great to be here. Thanks for having us. Followed all of you guys for a long time. Was lucky enough to meet Jordan in person at the Cyber Rodeo event, and yeah, just really happy to be here and just think this is such an important topic for conversation. I mean, way back in Battery Day when I was able to meet some of the, members of the Tesla community, I asked Elon the question around raw materials and, the spice must flow in my mind. So really excited to kind of get into this thing.
Jordan, how about you? Give us a little intro or background on yourself, if you wouldn't mind, about what got you started in batteries and what you're doing now.
I actually was... About 2.5 years ago, Galileo Russell, he had some theories on what Tesla might reveal on Battery Day, and I started looking into it and following the threads that he kind of tossed out there, and it opened me up to the complexity and all the options that might be possible with Battery Day. I started getting into it. I did a few YouTube videos to kind of put my thoughts out there, and I didn't think the YouTube channel would go beyond that, but what happened is I started getting feedback from experts, people in the community, etc., and then my knowledge upskilled, and then it was just from there. I found there's kind of an infinite amount to cover in the battery space, from the way the battery works to how they're manufactured to the raw material supply chain.
That's awesome. Yeah, no, you're very well respected for sure. I know Matt and I got to know another kind of hedge fund analyst or hedge fund manager who's been involved in Tesla for a long time, and they spoke very highly of you as well, and said I think they tried to poach you or something to work for them at one point, but you're more interested in doing your own stuff, and we really highly respect this hedge fund manager. So that's says a lot too. So we know you're very highly respected in the industry, and good signal versus lots of noise out there in this industry. So it's important to keep an eye on Jordan's YouTube channel for anyone who doesn't, with regards to battery technologies and such. So yeah, I guess we should just kick off the discussion. We've got a few things we're going to talk about: batteries, mining, demand for batteries, economies of scale, lots of things. We'll try to get through it in this roundtable. And Matt, do you want to kind of kick us off with any kind of questions or topics to?
Yeah, so I thought maybe it might be helpful to kind of anchor the conversation with kind of a discussion of the broad strokes of the battery procurement process, all the way from kind of mining to refining and battery cell assembly, and then ultimately making its way into the battery packs into the car. So maybe I guess Josh, maybe we could start with you and kind of what's the way that you think about the kind of broad strokes of the different areas and where are the current bottlenecks and then where might the bottlenecks be, maybe 5 years down the road as all the different OEMs, not just Tesla, are trying to really scale up, their battery or their EV production.
Yeah, absolutely. I mean, for me, it really does start with the mine, and that's why I got so interested in this area of study. And there's some great people you can go and follow on this subject, and that's really why I'm gleaning from like industry experts across the whole field of mining, but particularly around obviously the battery metal space. There's people like Benchmark Minerals. Simon Moores on Twitter is a great person to follow. The Global Lithium podcast is absolutely excellent. Joe Lowry's been an expert in lithium space for decades now and really goes into detail about all the issues that are currently happening. And even people like RK Equity, both Howard Klein and Ronnie Hooper, who you've seen on other channels, they really know their stuff as well and have a Rockstock channel. So I'd highly advise people to watch those kind of sources of information for more about this. But really, it starts at the mine because there is no battery without those raw materials. And as we know, there's a number of different chemistries and a number of different things that go into the battery. We have things like lithium iron phosphate batteries. We have nickel-based lithium batteries. But the key element in that is always lithium. And lithium is the one element in the battery that you really can't do without. So, when we start talking about what's most important in the battery space, for me, it's always come back to lithium. And when I asked Elon that question at Battery Day, and I said the spice must flow, really I was thinking about lithium because I knew it was that key core element. And, typically, obviously, OEMs try to strike long-term agreements with either battery makers, whether they're getting their batteries from Cattle or LG or someone else, or they might do what Tesla's doing, which is going much further up the supply chain, actually making agreements for the raw materials themselves. So they're not relying on those battery makers. And so they'll do some long-term agreements with, say, lithium producers. Like one of the biggest in the world is a company called Albemarle. Tesla has tons of long-term contracts with Albemarle for lots of lithium carbonate and hydroxide, which is the pure refined versions of lithium that you really need. And so they'll have these long-term contracts to kind of make sure that they have enough material for their supply for years going forward. And we can get into this further later in the talk that we're having here, but really the issue is that the battery industry can scale much faster than the mining industry can for a number of different reasons we can get to detail. So that's really the thing that kind of goes off my mind when I'm thinking about where the bottlenecks are.
Yeah, and I'm curious, just as we go forward, I mean, there's been a lot of speculation recently that Tesla may enter the mining business. Elon recently, he had this interview with John Kreider, and he essentially said that, he doesn't really want Tesla to get into that business. And Jordan, I know this is something that you've kind of speculated on before, that, there could be, either Tesla doing outright ownership of kind of mining, but they may also just have kind of strategic partnerships in some meaningful way. I'm curious, what's your kind of thought on how they ensure that the spice will continue to flow, as Josh said, with thinking of all the different bottlenecks and just how complicated it's going to be for them to continue to compound at 50% growth, to reach these really ambitious, multi-terawatt-hour targets that they've got for the longer term.
Yeah, there's a number of vectors that they have. Now, when I hear Elon say that Tesla doesn't want to get into mining business, well, I think that's true. Tesla doesn't want to get in the mining business because it complicates their business model. They don't want to spread themselves too thin. That takes engineers, time, resources. So if they can get other people to build those mines and produce those raw materials, they will. However, as Drew Baglino said on the last earnings call, Tesla will do what they must. So if Tesla needs to get into mining, they will get into mining. They'll do whatever it takes and whatever they can do to accelerate the world's transition to sustainable energy. Now, there's another question in there, but it slipped my mind. I got on this path about whether Tesla will actually get into mining.
Yeah, so I mean, I guess how are they going to ensure that once the lithium processing, which I think is the kind of current bottleneck, right? In order to continue to scale at 50% compounded for the next roughly decade, how are they going to ensure that all the other pieces will fall into place too? Particularly considering how long the permitting process for mines can be. To me, it just seems like there's kind of this inherent crash coming where there isn't enough new mining capacity coming online, but I know you're following this a lot more closely than I am, so I'd be kind of curious your thoughts on how you bridge that just raw materials gap.
Yeah, I think one of the easiest ways to do that is what they're already doing. They're using other battery companies as proxies, because most mining companies don't want to put all of their eggs in one basket into one battery cell manufacturer. So if the mines are spreading their materials out across several different battery manufacturers, well, how do you get more of those battery raw materials? You buy battery cells from more manufacturers. And we've seen this with the rumored or confirmed plans for Tesla to buy batteries from BYD. Samsung has plans to sell like 4680 battery cells to Tesla. At least the latest information I have is that that's their intent. They want to produce these 4680 cells and sell them to Tesla. So Tesla, they currently use about, I don't know, a fifth to a sixth of the gigawatt hours of battery cells that are produced. So if they can just take a larger proportion of the amount of battery cells produced, they can continue to scale at 50% per year. Now, I don't know how long that'll last. I think eventually they're going to come up to a wall where they might have to get into mining, or they might have to start building lithium refining equipment. But yeah, to me, that's the easiest vector. But,
I mean, I have some thoughts on that as well. I mean, when I think about this problem, to me, it's a huge problem. I think the lithium industry doesn't have the ability to scale very quickly. There's lots of permitting issues in mining, bringing new mines on as it is. And the lithium industry has typically been extremely small until the advent of EVs. Whereas, industries like the nickel industry, which is, Jordan very rightly pointed out in one of his latest videos, is like 25 times the size of the lithium industry. That kind of industry, to me, has more room to flex. If they can just put 5% more output out, that's going to help produce enough material from all these existing mines that are doing mining for nickel, for things like iron processing and other things that it's used for. But the lithium industry has always been tiny and now has to scale kind of, tenfold in the next 10 years, or even, maybe just 8 years if we want to hit targets for 2030. Benchmark Minerals put out a thing saying that all of the planned capacity for batteries, for 2030 adds up to about 6 terawatt hours at the moment. But that would require 5 million tons of lithium. And at the moment, the whole industry is less than 500,000 tons. So we're talking about 10xing in 8 years. I just don't see it happening. And in fact, the experts that I'm following are saying maybe 3 terawatt hours won't even happen. Maybe it'll be more like two something. And then when you're looking at that kind of levels, if Tesla wanted to do, let's say 10 million vehicles in 2030, they'd probably have to take 25% of the world's lithium output at that point, which maybe is just about doable. But, when you think about the 20 million target that, a lot of us Tesla bulls have hoped for and dreamed for, we've heard Elon being much more cautious around that number of late and saying, look, that's more of an aspiration. Don't get too hung up on 20 million by 2030. And I think that's the right way to go, because I don't see the lithium industry being able to react quick enough to have enough material to hit those numbers. So I think everyone needs to really get educated on that part, because I just see so many average Tesla investors kind of have all this wishful thinking, and they see these wonderful headlines about, maybe we can get lithium from seawater, or maybe we can get lithium from these unproven DLE processes. And the fact is, these things are maybe decades away. It's really unproven technology, and the stuff that is proven is going to take a hell of a long time to come online. So it's definitely a big problem to solve. And I think Tesla really needs to lock down that supply in any way they can. Maybe even buying out some of these big producers, but like Albemarle, I mean, they seem to have the balance sheet to do it. And for my money, that might be what they're forced to do, as Jordan was alluding to earlier.
Yeah. Josh, just to follow up on that, the lithium industry as sort of a major bottleneck potentially. During Battery Day, Elon referenced, I just found the quote, says, we found that we can actually use table salt, sodium chloride to basically extract the lithium from the ore. Nobody has done this before, to the best of my knowledge. So I remember that part of the presentation, and it seemed to cover initially the concern that a lot of, to me, it felt like, this covers a big concern about the lithium bottleneck, maybe, but do you think they've made progress on that, or was it sort of just too early for him to spout that and kind of more experimental still, or what are your thoughts?
Yeah, I would say no. And part of me gets a bit conspiratorial. There were the CEOs of the largest lithium companies in the world sitting in those Teslas with us, watching that presentation. And Elon and Drew and the leadership team were about to go into negotiations for more long-term contracts. So to me, it could be that it was more of a negotiating tactic to say, hey, do we really need you if we're going to do our own thing? But what he's talking about is mining from clay deposits, and it hasn't really been proven out as of yet. There is no large scale clay lithium mining that happens today. Now, that's not to say that it won't happen in the future. I'm sure these kind of technologies will be developed. But what it does mean is you have to bring a new mine online, and especially if he's talking about Nevada, which he talked about having the land rights to. Well, Nevada is federal land, and there are a ton of permitting process in the US that make it so that new mines coming online typically can take 10 years just to get the permit. This happened with Thacker Pass, Lithium Americas. recently, and they just got their permit after 10 years. And so great, some more supplies coming online. But to get a new plant up and running is going to take 10 years. So it's going to be too little too late in terms of the medium term. Yes, I mean, obviously, eventually these new technologies will come online and eventually they will solve our problem long term. We're not going to run out of lithium and we'll find new ways to extract it. But the problem is things like government regulations, things like geopolitical issues in the places where the lithium mines currently are, whether it's South America or other places. And so, yeah, it's for me, I'm not convinced that will solve the problem before 2030.
So you mentioned the difficulty of getting to 10 million cars, let alone 20. But then the other piece of the equation that I think people forget about too is that Tesla also wants to have roughly, I think it was another 1.5 terawatt hours dedicated to stationary storage by 2030. The kind of scale that they're talking about on both sides of the business, auto and energy, is really just kind of astonishing. And the latest kind of news that we've heard from Elon about Master Plan Part 3 is that that's entirely related to solving for scale. So I'm curious if either one of you have any thoughts on, okay, well, if mining, it seems like based on some of the comments we've heard recently, is not top of mind for Tesla. What pieces do you think we may learn from Master Plan Part 3 that maybe your average Tesla investor is not thinking about? I'm curious if you guys have any thoughts on a sneak preview of sorts of what we might.
Well, there's certainly one wild card for stationary storage that Jordan recently alluded to in one of his videos, but also Drew Baglino talked about in his recent talk with Stanford Energy, of which he's an alum of. And he was talking about the fact that, that's part of the problem with lithium and why lithium is so essential is it's the only essential element in the battery. However, CATL have developed some sodium-ion batteries that does replace lithium. The problem with these sodium-ion batteries is they don't have the energy density. They're a lot heavier and they take a lot more room. And so you're not really going to use these for cars. They're not going to have the range that you really want for a car. But if this technology can be proven, if it can be scaled, if it can be there for the right cost, you could use it for energy storage. Now, those are a number of big ifs, even to use that for the energy storage. This is still fairly unproven technology. But Jordan, you might have more information than me around sodium ion and how likely it is to scale to, say, terawatt hours by 2030.
I think in a really aggressive case, we'd see 1 terawatt hour of sodium ion by 2030. But I think that's super aggressive. There's
right.
Some companies where their base case for sodium ion is more like 20 gigawatt hours by 2030. Mm-hmm. It all depends on how quickly CATL is able to prove that technology out, how quickly the market develops confidence in it. I think it is a chemistry that has a huge amount of potential. I think at this point, it's sort of a fait accompli. So we will see it, but the question is how quickly it takes to get that to scale. Because it's not just about building a factory that produces sodium-ion batteries. You have the entire supply chain from where you mine the material to the refinery, and it'll take special refineries to refine the chemicals for sodium-ion batteries. You just can't use table salt or something like that. Battery chemicals are specialty chemicals. They're extremely high grade and have very difficult requirements to meet if you want it to go to a battery, because these batteries have to last for thousands of cycles, and any impurity can throw the entire system off.
Jordan...
Go ahead.
I was going to say, Jordan, I think in one of your videos I caught recently, you mentioned the importance of China and the Chinese government just being able to move fast and the regulations not being an issue for China to a large degree. Do you think, with how fast China's, like the strength of the Chinese government is just like, the regulations don't, like the Chinese government, when it has this mindset, it does it. The regulations don't get in the way, versus like every other Western country regulation government we know of, right? So do you think that the strength of the Chinese government, if they go balls to the wall, like so to say, for making the sodium ion chemistry work with CATL being a Chinese company and such, that they could actually get to that? Do you think they could potentially, if Chinese, how fast they build factories and, it's crazy how fast they build bridges and all that. I mean, the supply chain, like you said, could they do it all in-house within the Chinese infrastructure if they wanted to, do you think?
this is something I still need to look further into, because the thing is, like right now, the Chinese supply chain, yes, they can ramp quickly on the manufacturing end, but where are they going to get those mined materials from? Typically, it's from outside of China. You have all these supply chain flows that are going from all over the world. I think Elon referred to it at Battery Day as the thousands of kilometers each one of these lithium atoms has to travel to get into a battery cell. Well, so yeah, China can ramp quickly on the manufacturing end, but where are they going to get the chemicals? And from memory, I don't think China has a big stockpile of sodium. I think most of the world's reserve of soda ash, or whatever it's called, is in the United States. So great if they can ramp those factories quickly in China, but can they do it? Can they actually get those materials out of the ground in other countries? And well, that I still need to look into that. I don't know the answer to that.
Yeah,
maybe
that's a great point.
Not.
And one of the things I think about is also cost and grade. You were mentioning this before, Jordan. When it comes to lithium, for instance, there have been some Chinese entities that have said, "Oh, we've got this great ore called lepidolite in China, and we think this is going to plug the lithium supply gap." Well, the problem with lepidolite is that the grade that it's at, it takes a lot more processing, a lot more cost to bring it online commercially. And so it's only viable right now at the current prices that we're seeing today. But the minute you have any slight pullback, those mines are not going to be economically viable and will go out of business. And so you can't really rely on supply of that type of ore. So it even gets that kind of granular as to what supply you can bring on. Is this resource really economically viable? Because as we've been saying for a long time, and Elon's been saying, there's lithium everywhere in the Earth's crust, but is it in such concentrated quantities and in such a geological, fixture that it's economical to get that out and sell it at a profit? Often the answer is no. I mean, there's probably lithium in the soil clay in my back garden, but you're not going to make any money off of it. So that's really a key part of the equation here, as you were saying, Jordan.
Yeah, and it's lithium mines. You can't mass produce mines because every mine is different. Even within a mining site, if you go down 10 feet or 20 feet, the chemical composition of the material being pulled out of the ground is going to be slightly different, and you have to adjust your process to accommodate for that. So, every mine is bespoke. It's its own beast that requires its own flow sheet to produce the chemical. So it's that on top of the permitting requirements make mining really hard to scale quickly.
And so, I mean, it does, with a lot of the permitting issues that we alluded to, in the United States and a lot of the other Western countries, it does seem, to a kind of hobbyist observer that, the Chinese may be more successful in kind of moving mountains, literally and figuratively, in order to extract, some lithium. And to me, that kind of begs the question is, if that sort of scenario pans out where, the Chinese government is a little bit more aggressive in say, getting ahead of this, supply issue, who might be receiving the bulk of the supply going forward? So should we expect, the BYDs and the NIOs of the world to have kind of, first rights for some of these resources if China truly is, leading the way in new mines? So I guess maybe it's a two-part question. One, do you think China will be more successful in kind of leading the path on extraction of lithium? And then if so, how does that kind of, you got a set supply, and how does that get divvied up between all the different OEMs that, have very aggressive kind of expansion plans?
I'll throw my 2 cents in here and we can go from there. But from my perspective, it depends on how much the Chinese government puts their thumb on the scale for local manufacturers. At the moment, it's pretty much free market, and whoever can afford those battery cells gets the battery cells from these Chinese companies. If that continues to be the case, then, well, Tesla won't have much to worry about, because Tesla has big margins to play with. They have deep pockets, and they have the most capable engineering team to be the most versatile and use different types of battery packs and battery cells. But now, if every one of these Chinese companies has Communist Party members in those companies, and what if we get to a situation where the supply is so restricted, and China decides they want to start prioritizing companies within their own country? I don't know if that's. I don't know the likelihood of that at all. I don't know enough about geopolitics and the way the party operates there to know how that would play out. But maybe somebody else can.
Yeah, I mean, you make good points, Jordan. And I think, as you alluded to earlier, the good thing is, from a geopolitical standpoint, that China doesn't have a stranglehold on the actual raw materials themselves. These materials are coming from Western Australia, they're coming from South America. So, more refineries are going to be put online. Tesla has plans to refine the material themselves or make the cathode themselves. A lot of those things are the things that are being done in China for processing points of view. And those things can be onshored in some sort of geopolitical event. I think the key thing is making sure that we have access to the raw materials, and countries like Australia are very friendly to America and the EU. So that feels good. But then, like you said, how does that get divvied up regardless of where it's coming from? I mean, obviously, you just look to the largest EV makers in the world. I mean, the list from last year was, Wuling, and GM's Wuling Mini was kind of, number 2 in terms of units, but obviously it's a tiny, tiny battery. So the battery side, they're probably a lot less than Tesla, than the unit number would suggest. Then you've got Volkswagen, close behind with a few 100,000, BYD in the hundreds of thousands, Hyundai did a few 100,000s. And I think there was a mix there of both pure EV and PHV EV. And so I think having scale allows you to negotiate better with those companies, whether it's battery companies or raw material suppliers, because those companies, not only do they want the best price, but they also want the security that these companies aren't going to not be around in however many years this term contract is for. So maybe they would think twice if it was, I don't know, a Rivian or a Lucid or someone a bit untested that didn't have the scale yet. I would be, you'd think that you'd want to pick the company that's going to, definitely give you that supply. But there will be a fierce fight from the companies over this material. I mean, obviously, Tesla's been ahead of the game for years. They were the first to create kind of a battery metals division and have procurement teams for that sort of thing. But, the likes of VW and others are catching up and building their own teams. And that's why it becomes so critical to find ways to really lock in that supply, because we saw deals, off-take deals that we heard about from Battery Day with Piedmont, for instance, Tesla and Piedmont for X amount, 20,000 tons a year. But these agreements, they're not always like 100% cast iron. Piedmont's unproven as a miner yet. They still haven't produced any material. And so really you need to go further in helping these companies to secure the supply. Sometimes you're going to need to actually provide the financing for these junior miners, because it will be a lot of junior miners bringing on new supply between now and 2030. And it's a hugely capital intensive business. We're talking maybe like more than $1 billion to bring on some mines. So there is a lot of need for capital in the industry, and a lot of the time they're not getting it. So there was an article, I think just a few days ago or a month or two ago, that Ford was entering into agreement that was providing a lot more financial help to set up this kind of mine. So I think we're going to see a lot more of those type of deals that aren't just off-take agreements that have no financing behind them, but actually have the dollars behind them. And who knows, maybe Tesla would buy out a big company, a big lithium kind of conglomerate. But as they've alluded to, they don't want to do that, but they've also hinted that they won't not do that if it's absolutely necessary. And if there's a huge dogfight over this material between all these large companies, Tesla might have to do that.
Yeah, I mean, that's a good point you bring up, Josh. And you alluded to something about, the batteries supplies being locked up a lot by Tesla, for a year. They're years ahead in this space. And that, being such a Tesla fanatic and bull for so many years, the biggest argument I hear from others is like, the competition is coming. They're coming. They're coming. And I always think about well, if some other car company like Audi or Volkswagen or Porsche or whoever, is going to really compete with Tesla in terms of building, mass market EVs, where's their battery supplies coming from? I want to see that first. And I can't find proof of any other company coming close to the scale of battery supplies as Tesla, except for maybe Chinese EV makers, within the Chinese infrastructure, including BYD, XPeng, Niao, and so forth. But as far outside of that, what do you guys see as the next, competitor to Tesla in terms of locking up battery supplies? Is it Volkswagen? Is it Ford, GM? Or is there some other company, Stellantis? I don't know. What do you guys think? What are your thoughts on that?
Yeah.
Josh?
I mean, I definitely think Volkswagen's in the mix. I mean, they had their version of battery there, forget the name of it now. And they laid out a few of these plans. They want to go further up the upstream, just like Tesla has. They're following the playbook. As one of the leaders at Battery Day said, one of the Tesla leaders said, yes, we're doing this. This is quite novel. This is new like lengths of vertical integration. But that's not to say we're the only ones that can't do it. And yes, it does look like Volkswagen is serious. And we obviously, we've all been following Herbert Diess. And he seems like one of the more serious CEOs about the transition to EVs with his rhetoric, with his actions. So I definitely put some stock in him. But there's probably others too. Jordan, what do you think?
Yeah, Volkswagen would be the company that I would think of first outside of China because, as you said, China is they're in a really good position with regards to battery materials. But there's two factors that I look at here, and one is are they lining up the battery raw materials, and two, which companies are going to go out of business? I'm not convinced that all the other auto manufacturers are actually going to make it through, even if they do line up their raw materials. And just looking at their balance sheets. Behind when I look at Ford, I see the products that they're making, and I like the EV products that they're making, just based on what I've seen with the Sandy Monroe teardowns. But I haven't seen as much activity from Ford in the mining space as I have from GM. But I don't care too much for the products that GM has come out with. With all that said, I'm not following all these other companies as much as I'm following Tesla. There's actually room for two or three other channels doing what I do with Tesla just to keep up with all the news that's coming out of that company every day.
I think it's easier to point out the ones that we think will fail the hardest than, you hear a lot of rhetoric from companies like BMW CEO has been very anti-EV for a long, long time. And another one that comes to mind is Toyota's CEO. And I know some people that have lived in Japan, and there are some cultural barriers there, can be sometimes sort of barriers to change. It's not like a culture known for fast-paced innovation and change. And yeah, Toyota's another one where they've been dragging their heels. They've been putting more and more money into hydrogen, which really isn't going to go anywhere. So it's those companies that I worry for the most and think, how are they going to turn this around when you have the likes of VW and even Ford, being more aggressive and going up chain and securing battery, whether it's batteries from battery suppliers or actual raw materials.
And it's worth taking into account that Tesla's already at such a different scale than Ford and GM. Yet Ford and GM, they can secure these pockets of resources, but that's just enough to maybe get them started. I don't know how much scale that will allow them to get. Whereas Tesla, they're looking at, they need to acquire much greater quantities of material because they're.
Hey everyone, apologies for the interruption here. Unfortunately, we had some technical issues with my part of the video feed in this segment of the video. So we lost the question where I was asking Jordan about the kind of the state of his 4680 battery cell teardown, specifically what he's finding right now around energy density of those cells and if there's some improvements around there. So with that, we'll cut it back over to Jordan's answer.
Yeah, so I'm still working on getting energy density figures. So based on what I see so far, I don't know if the energy density is actually going to be that much higher than a typical standard cell right now. So in terms of the efficiency use of the raw materials that go into their battery factories, just from an energy density standpoint, it doesn't look like it's any different at the moment. But what I'm seeing from the teardown is they're laying down a better first principles platform to continue to improve energy density and to continue to improve efficiency over time. And we also have to take into effect is not just the energy density of the battery cells, but the efficiency of the factories themselves. Like my understanding is the cathode process that Tesla's using is going to be like a zero waste process. And the dry battery electrode technology that I'm assuming they're using at the moment, I still need to confirm that, but it should allow for more easily recycle scrap electrodes within the factory. And then on top of that, Tesla has their own in-house recycling program that they're developing. So they're doing everything that they can to squeeze every battery cell out of the material that they have. And over time, I expect them to have higher energy densities than other battery cells in the industry, which will allow them to use less raw materials for each battery cell. And that's in terms of things like nickel, copper, stainless steel, etc. Because an interesting thing about battery cells is whether your battery cell is 300 watt hours per kilogram or 250 watt hours per kilogram, to store the same amount of energy, you pretty much need the same amount of lithium. All you're doing is you're just stripping out all that other material like nickel, copper, stainless steel, but you still need roughly the same amount of lithium for a battery cell that has like an equivalent voltage. I don't know if I answered your question. I go off on these tangents. And I catch myself. But yeah, so the efficiency with their factories, yes, their factories should be more efficient. But I expect everybody to get more efficient over time. And in terms of their energy density, I expect that to.
Okay.
The dry battery electric technology is going to be pretty impressive, I think. I think that's what's in the cells. I still need to confirm it. But
I mean, obviously, another key way that you could bring down the usage of the battery materials is to make a smaller, lighter car, which would, we've all debated the name, the smaller, compact, cheaper than a Model 3 car, whatever the price ends up being. It's not going to be $25,000 a car with the inflation that we're seeing. But that would be another great way to bring down the cost. I mean, obviously, there's talk of, hopefully maybe one day robotaxis, which, I'm still a bit more on the fence about that part of thing. I think they can make tons of money even from driver assistance thing. It's still yet to be proven that they will fully, complete the robotaxi. But even if they don't, they can make a much smaller, nimbler car that uses less batteries, less material. I mean, if you're in a city, how many miles are you driving a day? How many batteries do you really need? And there's definitely hunger for a much cheaper car that would use less batteries anyway. And we're seeing this in China anyway. Obviously, the Wulong Mini is tiny and has tiny amount of batteries. But that's all you need if you live in a city. And I think, the latest statistics for how many people live in urban areas in the US is something like 80%. And that obviously includes the suburbs. But yeah, so I think for me, that would be a key way to bring down the need for so many batteries.
And there's one thing I forgot to mention is efficiency. So Tesla's vehicles, their powertrains, et cetera, are probably about, 10 to 20%, at least 10 to 20% more efficient than other equivalent vehicles. So I think in that sense, they can get more out of their materials just by being about 10 to 20% more efficient with their powertrains.
So do you think that this 4680 cell, I mean, it seems like it goes with the structural pack, right? I mean, can you explain to us, Jordan, I guess, the current 2170 structure and how that cannot be part of a structural pack? And then the structural pack is the way, I guess, Elon's mentioned it, is like, putting the fuel of an airplane into the actual airplane wing instead of like creating a separate fuselage for the fuel. So you're actually just making the fuel part of the airplane. So I guess the structural pack, maybe, is it like making the batteries actually part of the car, like the bottom of the car, instead of a separate pack that you have to put into the car? Is that right? Or can you explain that a little
so
bit?
Basically, with the 2170 battery cell, they're about, it's about the size of my finger. And you have thousands of those battery cells within the battery pack. Now, within that battery pack, you put steel beams within the battery pack to create rigidity, and then you mount that up underneath the vehicle. And it's not really part of the structure of the vehicle. So there's a lot of duplication and excess waste there, because there's actually enough structure in those battery packs to become part of the structure of the vehicle, but they're not doing it. They've been overbuilt historically. So what the 4680 battery cell does is, as far as I can tell from the teardown, the cell can of those battery cells is about 2 to 3 times thicker than a typical battery cell. And what you do is you set those hundreds of those 4680 battery cells, because they're about that big around. You set them in a pack and you fill it up with epoxy, so it forms like a monolithic honeycomb type structure that has really extraordinary torsional rigidity. Now, what you do is, you don't need steel beams running through that anymore, which were just dead weight. And then you actually make that part of the structure of the vehicle. So there's no duplication. The battery pack gets bolted in, that fixes it in place, and it keeps the vehicle from twisting. So you've stripped out the duplication between the pack structure and the vehicle structure, and also you've stripped out all those steel beams within the pack itself. So it should be I don't know if they're that. I think with the current iteration of the structural pack, it might not be as good as people have expected from battery day. I think they might be super safe and super careful with the structure of the vehicle, and then over time they'll realize the full benefits of the structural battery pack. Mm-hmm. And this is what I was saying earlier about Tesla creating a first principles platform, and then over time that should allow them to overtake other potential technologies that are out there. Regardless, it's going to be cheaper because Tesla is producing it in-house. They're fully vertically integrated from a cell and pack perspective now.
And from all your analysis, Jordan, that you've been doing on the batteries for all this time, and the 2170s and the chemistry, and now the 4680 you're starting to tear down. So far, I know it's early days of your kind of studying the 4680, but what do you think the likelihood of Tesla succeeding with mass scaling the 4680 is? Do you think that it's possible they may never be able to mass scale it? Like there's going to be inherent problems with mass scaling it for some reason, or is it too early to tell?
I haven't spent enough time on manufacturing lines to be able to get a good indication of that. But the thing is, at the moment, my understanding is they're producing about 1 million battery cells a month. And I think that indicates that it's just a matter of working the kinks out of the system. Once you're at a volume that's that high, you're actually already on that production S-curve. And I don't know of any situation in the past, it just could be from my ignorance, but I generally, it's at the first part of that, the very early part of the S-curve, where you're just making like a few units a day or something like that, where you run into challenges that you just see that can't be overcome in the long term. But Tesla's already at a point where they're producing millions of cells per month. So it's just a matter of, all right, how can we accelerate this now? The process works. It's just a matter of increasing the throughput. That's my perspective. Throughout the rest of this year, Tesla should keep us updated on the earnings calls. But based on what Drew and Elon are saying, they have a high degree of confidence in it. They've encountered more hiccups potentially than they expected, but they see a pathway to volume production, is what I've gathered.
So, Jordan, one other thought that came to mind when you were speaking, you talked about the kind of thickness of the can of the 4680, and in watching that teardown video, it was almost comical how difficult it was to actually cut into the outside wall of that and access it. I mean, I think that guy was sweating pretty heavily. I would imagine by how much effort was going into it. So I think your point is well taken that there's potentially some over-engineering to make sure that they're safe on that front. But with everything that you've said, maybe the energy density of the battery itself is not improved, but still the battery efficiency from a vehicle perspective would be improved, right? Because you're taking out a lot of the dead weight, essentially the steel support beams like you were talking about that are not needed. So when you zoom out, I think you are still seeing an energy density benefit overall from the 4680 program, even at this early stage. Is that a fair assessment?
Potentially, we don't know yet, because some of the weight figures that we've been getting out of these Texas-made 4680 Model Ys have kind of thrown everybody for a loop, because everybody's like, well, shouldn't the vehicle be lighter than that based on this technology? So we don't know yet. It's early days. This is the first version after the prototype version that we're seeing coming out of these factories. So I don't know. I think the battery pack will be a little bit lighter overall, but I don't think it's certainly going to be as extreme as what was promised at Battery Day. And I think they will get there. Bear in mind that at Battery Day, they said this is kind of what we expect in 3 years. And it's been, what has it been? Not even 2 years yet. So we're at the halfway mark. And they're putting out their first prototypes. And as we've seen in the past 6 months, just with the cell design has changed drastically in the last 6 months. And I expect that's going to continue with the castings, with the structural battery pack, and the cell itself.
And this teardown that you're in the midst of right now for the 4680 cell, that, as you mentioned in the beginning of the video, I think it's a battery from 4 or 5 months ago, too. It's not like a current battery they're producing. So it could be very different. The battery, it could be different in a number of ways, I guess, the batteries they're doing, the 4680s they're doing today versus 6 months ago, right?
Correct. Yeah, because the cells that they showed us at Austin were very different from the cell that I tore down. I'm working on tearing down. like just the bottom of the battery cell. The one that I have, there's like a rubber ring around the bottom, and then it's pretty just, concentric circles at the base, and then there's like a little copper plug. Whereas the ones we saw at Battery Day, there's this complex alien-like pattern that looks like it's been etched into the bottom of the cell. So potentially if the cell blows out, it'll just kind of fold outwards, and they've kind of created places, weaknesses where it can blow out there. And I also don't see like a rubber ring around the bottom. So that might help the battery cell cool a little bit better too, because it's being side cooled rather than on the bottom.
So one last thing about I wanted to ask you and Josh on before we talk about maybe different technologies and such as the chemistry. I think in your recent video, was a sodium ion chemistry that CATL put out. I mean, does that involve no lithium? Is that the case? And so that would eradicate the lithium bottleneck issues. But there's still mining that needs to be done, right? I mean, there still would be potentially mining bottlenecks as far as you or Josh know, do you think, in the sodium ion version?
Yeah, so I don't know if that question was for Josh or for me, but yeah, for the sodium ion battery, it's first off, you're replacing most of the metals in the battery are the same on the cathode. You can use nickel or iron or manganese in a sodium ion battery cell, and that's most of the metal that goes into a battery cell. But as Josh was saying, because all of these chemistries, regardless of whether they're nickel or iron, all of them use lithium, that creates a bottleneck. So you have to replace the lithium with something else. So you can do that with sodium and have similar cathode structures with a sodium ion battery, just replacing like the sodium atoms in there. However, because a sodium ion battery is a different chemical system, it requires a different anode material. Like you use a hard carbon anode instead of a graphite anode, which is a different material. And then on top of that, instead of using copper and aluminum current collectors, you'd use aluminum current collectors. So it changes the supply chain quite a bit when you move to sodium ion.
And then I remember you mentioning earlier that, obviously there's, the kind of prospective amounts that they think they'll produce aren't going to be crazy amounts. I think your upper end was 1 terawatt hour, but more likely it might only be like 20 to 200 gigawatt hours or something. Is part of that just because it's so new? Is it just such a new technology that it's going to take longer to ramp?
Yeah, well, we've been working the kinks out of lithium-ion batteries for 40 years now, or no, 30 years now. We've been working the kinks out of them. So when you're dealing with sodium, you're dealing with a different chemical, and it's going to have, as that works its way through the supply chain, there's going to be different challenges with a sodium-based chemistry. Like it might have more sensitivity to moisture, for instance. And then people think that as soon as you have a battery chemistry, that's it. Then all of a sudden you can just start cranking out millions or hundreds of thousands of tons a year. But that's not the case. What you do, you have to come up with a recipe that consistently produces the product that you want every time. It's kind of like if you wanted to start a factory making cookies. You'd have to spend several months or several years just getting that recipe right to produce a cookie that comes out exactly how you want it each time with the right characteristics. So, yeah, and it's like that every step of the supply chain. When you extract that material from the ground, you have to get that chemical recipe right to get exactly what you want out of it. When you take those processed materials and you combine them with the other materials, you have to get that recipe right to make sure that you're producing the right end product. And then you have to understand how that end product performs, the end chemical product performs in the product itself. Yeah. So each one of those things is going to have kinks that have to be worked out. And on top of that, you're working from such a small scale. There's not that many experts out there on sodium ion, whereas with lithium ion, it's kind of like what we were talking about with lithium and nickel before. The nickel industry is 25 times the size of the lithium industry, which gives it this bulk of expertise and experience that allows it to scale more quickly. With sodium ion, we're starting from zero. So you have to go from zero to hundreds of gigawatt hours. It's going to take a long time to get all those people trained up and familiar with the eccentricities of that chemistry.
Now, we mentioned something about the chemistry, mixtures and such. Back to the lithium battery chemistries. Just as I think they cut down the cobalt to like be near zero, or was the nickel or cobalt they cut down to be near zero in one of their battery cells. Is it possible you think they can cut down the amount of lithium in some of their lithium battery chemistries to be even less, so that, a pound of lithium could create 10 times as many batteries in the future as what it could do today or something? I mean, do you think that's possible or not? Is that more wishful thinking, or is it hard to say?
It would be, it wouldn't be multiples. It would be percentage improvements. And what you do is, for instance, you can increase the voltage of these battery cells. And that's what Elon was saying with manganese. For instance, manganese tends to create a higher electrochemical potential than, for instance, if you have a lithium iron phosphate battery. If you add a little bit of manganese to that, you can get the voltage closer to the voltage that you see in a nickel-based battery cell. So you're using the same amount of lithium, but there's just more chemical pressure within that battery cell. So it'll allow you to maybe get, 20 or 30% more battery cells out of the same amount of lithium.
So you were talking just a minute ago, Jordan, about kind of if you come up with a new cookie recipe, how difficult it is to scale. So I'm curious what you kind of think, and Josh, you as well. I'm not sure which one of you might be better suited to answer this question, but when you look at some of the kind of claims of huge breakthroughs in like solid state batteries, for example, some companies like QuantumScape have been kind of cheering brand new, I would say unproven technologies. But what's your thought on kind of these out there breakthroughs that some people would claim have the potential to kind of make the lithium ion batteries that Tesla is really trying to scale right now? Well, 5 years from now, they may be obsolete if, the most optimistic of these kind of solid state folks are right. I'm curious if you guys have any thought on what's the promise of solid state and how real is that at this stage?
I have a couple of thoughts, but I'd be interested to hear Jordan's take first.
The advantages of solid state are evaporating month by month and year by year. The potential that it held 5 years ago versus a typical lithium-ion battery was impressive and persuasive. But just a few days ago, CATL released some information about a battery pack that they intend on producing that's safe and has very high energy density. And that's pretty much what solid state is promising. Now, it's hard to say deep into the future what's going to happen. I think deep future, 5, 10, 15 years from now, I think solid state is the way to go because it has some first principles advantages. But what lithium ion it has right now, thousands of factories out there, or I don't know how many factories are out there, but there's, thousands of people involved making these lithium ion batteries, improving them. And there's all this capital that's already invested in that. So it has this inertia, this mass, and people already working on it. So it's there's a lot of improvements that can continue to be made with lithium-ion battery cells. It may take some time for solid state, those first principles improvements to show. But what about right now? What do we know about solid state? The solid state batteries that are currently being released, despite how much they were hyped, the performance is similar to what we'd see in a lithium-ion battery because there's what's promised, and then after you make all those cookie recipes, after you actually get this into a product, what do you actually have? And right now, the performance is pretty much on par with lithium-ion batteries. And not only that, the safety benefits, theoretically there's safety benefits there, but anytime you have a battery cell, regardless of whether it's solid state or a liquid electrolyte battery, it's storing enormous amounts of energy in a small space, and it has the potential to explode. And we've seen that with 2 buses recently in France. 2 buses exploded that had solid-state batteries in them, and they had to pull the entire fleet of buses. So there's what's promised and what you get. So
yeah, I think
go ahead, Josh.
Oh, I was just going to say a good thing to add would be that actually, in terms of the raw material side of things, solid state actually needs slightly more lithium than a lithium-ion battery. So we're not, for instance, supplanting that bottleneck by doing solid state. So then what's the benefit? I mean, obviously it's promising at some point better specs, like Jordan's talking about here, whether it's longer range or more power or whatever it is. But in my mind, so what? I mean, do we need more range than we've got today? I mean, Lucid put out a car that's 500 miles of range. I mean, Tesla has a 400 mile plus range car today, and they'll do longer ones in the future with just lithium ion batteries. And, people are having a great experience with EVs today with 300-mile vehicles or even slightly less. So, really it's like, what need do we have to supplant all this capital and intensity when the battery that we have right now, as Jordan has rightly said, is really good enough for the job? So it's going to be a tough one to supplant the current lithium-ion batteries with solid state. Now, there might be other use cases. Maybe it's planes, or maybe it's boats, or, I don't know, because it's yet to be proven how well these things will perform in the future when they're fully, reach their potential. So maybe we see some applications there in the future, but I just don't see it supplanting the dominance of the lithium-ion battery, and especially not in probably the next 10, 20 years.
And what I'd like to add there is we need every battery cell we can get. I don't see any battery technology that comes out as a competing technology. There's such a, right now, we can only expect to get 50% of the battery cells we need, if that, by the end of the decade. The demand versus the supply, there's a complete imbalance. So these technologies aren't competing with each other. Every battery cell that's going to be produced, regardless of the chemistry or form factor, is going to be used as long as it meets the needs of the use case, and as long as the companies can make a profit selling them.
Yeah, that's super interesting. There's to me, there's an analogy in the energy generation space where people have been kind of touting fusion, nuclear fusion, for the longest time. Is like, oh, it's going to be the low cost, it'll be like free energy, abundant everywhere. But what you've seen is just, in the last 2 decades, what has worked technologically has been solar and wind. And so as people have started working on those, and as the supply chain has developed, and engineers have spent thousands and millions of hours probably just refining the design, the cost has just continued to plummet. And so now I'm kind of at this point where I'm like, even if fusion came along, kind of, so what? Like, it's the cost is already so low, and you're going to need a huge amount of kind of investment to get fusion up to the point where it would actually be economical to compete with kind of the current state of solar and wind. Sounds like there's a similar kind of dynamic going on with solid state. I'm curious, are there any other technologies out there that have you interested, or the other thing that kind of struck me as you were talking, Jordan, is if you really do think that solid state is the longer term answer, is there some inflection point that could happen 10, 15 years from now where Tesla could have all this investment in lithium ion manufacturing facilities, and it could kind of become obsolete at some point in time? Is that a risk that you see happening? And I'm just curious, longer term, how do you think through evolving technologies?
Generally, the way that battery technology is built, or most technologies are built, is the newer technology is built on top of the old. Once a specific technology meets the needs of a use case, then it continues to be used for that use case. But like, for instance, the 18650 battery cell that we see in the Model S, that's the same battery cell that's been going into those vehicles for like over 10 years now. So it met the need. We have those battery cell factories in place. Why shut those battery factories down or cut them over to something else? Because if Panasonic wanted to change that 18650 battery cell to, say, 2170 battery cells, just a slight change in form factor, those machines might be down for months. In the meantime, they're not making any profit off of those machines. You just fully depreciate the machines, you keep running them, and keep using those battery cells because it's too much of a hassle to cut over to something else. So all these new technologies, they're just going to, they're going to find new products and use cases, and it'll take time to scale those new battery technologies. It'll take, 3, 5, 10 years to scale them. Now, there is some flexibility built in there. We've seen Panasonic increase the energy density of their battery cells over the past 5 to 10 years just by making tweaks to the cathode and anode chemistry. So, and this is what I was saying, that the current market already has so much inertia. Why put all this energy and investment, et cetera, into an entirely new technology that requires entirely new factories when if we can just put a little bit of effort into improving like the current chemistry that we have, we can squeeze more out of the factory lines that we already have. And there's, the potential to improve current battery cells by, 20, 30, 40% simply by using the same battery lines.
Yeah, I mean, I think that's a good point you make there, Jordan, that like stick with what you've got that's working really well, and just if you continuously improve it marginally, it compounds over time, and it makes a lot of sense, especially because there's so many ICE vehicles to displace still. It's like, the EV fleet globally is less than 1%, I think, still, so yeah. It's, what's that, Jordan?
There's another thing to add there is, recycling. Right now, the amount of recycled material that we're getting back just isn't that great volume. But 10 years from now, 15 years from now, the amount of recycled volume of material that we're getting back from battery packs, et cetera, is going to be absolutely enormous. And that material should be a lot cheaper than the material that we're currently mining because we have to send it all around the world. We're taking rocks that have 1% lithium. We have to break 99% of that material away, refine it, ship it around the world. Well, here you have a battery cell that has everything that you need in it.
Yeah.
Run it through a chemical process, and we should be able to get materials a lot cheaper. So just from that perspective, it's going to be kind of it's going to develop a virtuous
economies
cycle
of efficiency and such. Yeah, Josh, exactly. I mean, you probably thought about, you've been focused on the mining a lot and the constraints with that. The recycling, like, that's a good point Jordan brings up. Do you have any thoughts on when you think the recycling will make a real dent in terms of the bottleneck of that we have right now with mining?
Yeah, I mean, like Jordan says, I think it will be another 10 or 15 years before we get there. Another thing to think about in the recycling piece is, how well do those batteries perform even when they're not performing well enough for an EV? So you could see scenarios where they kind of get a second life. They're no longer useful in a car, but maybe they could actually still be used without any recycling for stationary storage. We haven't sort of fully proved that out yet because we haven't had enough supply to really test that. But it's certainly possible. So you could see second life, third life applications of these even after the sort of 10 to 20 years or however long it takes for them to leave the EV, and then you'd be used in something else. So the lead time is very long. It will take 10 or 15 years to have any meaningful supply. But in the meantime, what recycling will do even today is help with improving yields. So, obviously as Tesla ramps up their new factories, as they ramp up their new battery, 4680 lines, there's going to be a lot of scrap initially because they've just never done this before. And, you're going to see scrap yields maybe as high as like 20, 30% of scrap when you're making your batteries. And so what do you do in that scenario? You've just, wasted 20 or 30% of your material today. Well, Redwood Materials, or in Tesla's case, its own in-house recycling team, can help get that those lithium and the nickel and iron back into your supply, X amount of time down the road. Now, it will still take maybe a month or more. I don't know. I don't know the processes well enough to know how long those lithium atoms or other metals will be delayed. But it's certainly going to help. And so that's really where I see the key, near-term help for recycling. And then in the future, absolutely, it'll be much easier to recycle stuff, further down the line.
Yeah, I mean, I think this is really enlightening having this discussion with you guys. A lot of this is very abstract to me in a lot of ways, not things I think about all the time. Obviously, you guys spend a lot more time thinking about it, so it's good to hear what you think about these constraints or bottlenecks. And it seems to me like a big takeaway I have from this conversation is that the biggest potential bottleneck for Tesla growing 50% per year for years to come might be the lithium they're able to extract or mine. Now to me it makes it more important. It makes it more sense of why the robotaxi introduction in the next couple of years is such a big deal for Elon and Tesla, because if there is a point where they can't produce as many 400-mile, 500-mile range cars. That's a lot of waste of lithium in a way, in a sense. You're putting it in a 500-mile range Model S that people drive 100 miles, every week on. Like that's a lot of waste of lithium that could be used in a robotaxi to, drive 500 miles every 3 hours or not 3 hours, every day, 500 miles every day for the whole week, and you can get 1 million plus miles out of these battery packs. I mean, so it makes a lot more sense that the robotaxi and getting this full self-driving technology online in the next couple of years, because that's where you're going to maximize, I think, the lithium as a resource in terms of creating sustainable transportation energy and displace the, ICE transportation wasteful resources. I don't know, Matt, you have any kind of takeaways or anything that stuck out to you?
Yeah, I mean, I think you're definitely right. And Josh expressed some skepticism on robotaxis before, and I'm kind of in your camp, Josh. Like, I think they'll solve it, but I don't want to bank on them solving it and kind of assume that that's a base case, especially in, say, the next 2 years. But the first principles thinking behind it to me makes a lot of sense, that you're increasing utilization and you can offset more kind of ICE miles that way, which is a very, that's clearly the goal, right? Is offsetting ICE miles as quickly as possible. But one thing that you guys brought up that got me thinking a little bit is just how kind of significant the potential supply chain constraint down the road could be. So when I've been talking to some Tesla bears in the past, a lot of them will say, oh, well, Tesla's demand will, kind of dry up because of, increasing competition. But I think some of what I've heard you guys say is, well, actually the bottleneck to, say hitting 20 million units per year is probably more likely to be on the supply side than on the demand side. So I'm curious, do you guys think that supply constraint is a bigger deal than demand? And if so, to me, it seems like there's really interesting pricing dynamics that could come out of there. One on the raw material supply pricing side, which is a cost. But also, if there's just not enough EVs to meet consumer demand, that could potentially give Tesla and other companies pretty significant pricing power, like we're seeing right now in the market, which may stay around longer than people are thinking. So maybe a two-part question for each of you. One is supply the bigger constraint than demand, and how do you see that kind of impacting Tesla's margins when you put it all together?
Yeah. No, I mean, you're absolutely right. In my opinion, the supply is 100% much more the issue than demand. I mean, we're already seeing year-long plus wait lists for Tesla vehicles. Scarily, I think we could even maybe in the not so distant future see 2-year wait lists if we're not careful and things don't go as we're hoping. So the demand isn't the issue. Like, people want EVs. I mean, we're all behind the mission, and I'm just so grateful for what Tesla's doing. Every time one passes me in the street, I'm not breathing in toxic fumes, and a lot of people resonate with that and they want EVs. I think the real problem is like you said, prices will have to go up if demand is that high and the supply isn't high enough. And that would be great for the business and great for the margins, but there will be a kind of social hit. Already we hear the kind of cries from people that, hey, EVs are just toys for rich people. And it was so exciting when Tesla was able to deliver the $35,000 Model 3 for a short period of time. But, we're up to $49,000. And while that is the average cost of an American car today, there is the majority of Americans who cannot afford $49,000 for a car. So, eventually that will come down. But if there is a protracted period where prices are high because the supply isn't there and therefore the production isn't there, I think we will see this kind of social battle around, are these just toys for rich people? But yeah, obviously on the investment side, it's definitely good for business. But definitely they'll want to do something to counteract that, and that's been Elon's push all along. He wants it to be an affordable car, and he's been very vocal about that from the word go. So they'll do everything in their power to make that happen.
Yeah. So if I'm hearing you right, though, and agree with everything that you said, but it sounds like you kind of think that Tesla will have more pricing power than they will have a hit from kind of increased raw materials costs going in. Is that what
Absolutely.
You would think?
Yeah, I mean, we've seen it already. they've been able to raise prices, and the wait lists haven't really gone down. And so, yeah, I mean, Tesla is the Apple of the automotive world. They have that kind of brands where people are just so excited about it, and the consumer, satisfaction surveys from Tesla owners are off the charts. And they have that desirability, and obviously Elon has star power. All these things factor into the brand that is Tesla, and they are clearly the leader in EVs, and people will pay the money, and people want them. So on that side, I'm very optimistic.
Yeah, I've been bullish for years on Tesla, but even I've been surprised that, I was assuming annual price decreases going forward for Tesla, but instead, the opposite has happened, and it doesn't seem to be going away. So I've been kind of surprised at how Tesla has surprised on pricing power and gross margins. I mean, just way higher than I thought they'd see. Jordan, how about you? Any thoughts on kind of those dynamics? Would you agree with what Josh said? Any different takes?
Oh, no, I absolutely, you guys are nailing it. I totally agree. What I would add is if they do get full self-driving sorted, that's where things get really nuts. And it could also solve the social conflict problem because, if they're restricted with their battery supplies and they can get five times more utility out of each vehicle that they sell in terms of transitioning the world to sustainable energy, which is what their goal is. Their goal isn't, their mission doesn't stay, their mission statement doesn't say, let's produce as many vehicles as possible. It's let's transition the world to sustainable energy. Well, the best way to do that in a supply-constrained environment where you have a robotaxi is to take every vehicle you produce, or as many as possible, and shift those to robotaxis. Then it allows more people access to low-cost transportation, and Tesla's margins go through the roof, well beyond whatever they'd be able to get just selling those vehicles individually. So it could get pretty crazy.
Great. Well, this has been a great chat with you guys. Thanks so much for coming on to talk with us. And, as tradition now with our interviews for the time being, we're in a fortunate position to donate to charity with the choice of our guests chooses. What charity, if you wouldn't mind, Jordan, what charity did you choose? And tell us a little bit about it.
Okay, so the one I chose was represent.us, and it's like a bipartisan nonprofit that basically says the reason why we have all these conflicts and all these issues in American society is because there's too much money polluting the system. You can view corruption as, kind of like a good and evil thing. But at its core, corruption is like a corrupt bit of data on a disk. There's something that's not working as it should be. And when you have this much money coming into the system from lobbyists, special interests, etc., that warps the entire incentive structure, and the politicians no longer serve the people. And then the people start getting angry at each other, etc. There's all these feedback loops that go into it. So I think in order to solve the problems that we're facing today at a broad level, because I think everybody can agree that things are pretty much a pretty big mess at the moment.
Yeah.
If we want to fix things, you have to take the corruption out of the system. So represent.us, they're trying to get laws passed through grassroots movements to reduce the amount of corruption at a local level, then a state level, and then like a national level.
That's
kind of what happened with cannabis legislation, where they started at the state level, and now, eventually, as all the states accept it, it'll probably eventually become legal at a national level.
Yeah. And I think there's a lot of corruption, especially at the local levels, that people are completely unaware of. There's no local newspapers anymore that used to be sort of a helpful watchdog on local politics. Everything's become national news, and there's some regional news, but there's no town newspapers that really thrive anymore to help keep an eye on that stuff. So I think left unchecked, a lot of these local politics things have gotten very corrupt. So hopefully that sounds like a really good cause to me. Yeah, thanks. And we'll donate $5,000 to that, as well as Josh. Which charity did you pick? And tell us a little bit about it. And we'll donate $5,000 to that one as well.
Sure, yeah. It's a charity called Change, Grow, Live, or CGL for short. And they help with a few broad range of issues. They help people with mental health issues. They also help people with substance addiction issues and maybe as well homelessness as well. And they have a number of different ways of doing that. Support groups, other services. But yeah, it's just a sort of an issue close to my heart. I've had sort of extended family members who have had mental health issues, and I think there's like a real stigma around that. And anything that I think can support that is really needed as a society. So yeah, Change, Grow, Live is a great organization.
Great. No, I think that's fantastic. I think those are all interlinked in a lot of cases too, like mental health and addiction and all that. So I fully support that. I think that needs more attention, and I think those are both great causes that you guys have brought up. So we're happy to donate to them.
And it's been great to watch the stigma around mental health really change. And I think that's, another thing that's continuing to improve kind of slowly but surely, but there still is more work to be done on that for sure.
Yeah, definitely. Yeah. And just, I got to say a big thank you to you guys for doing this kind of stuff. I mean, it's very refreshing to see, like, you guys have always been very community minded and like giving back. And that's such an amazing thing to do. So, big thanks.
Yeah, no, thank you. Yeah, I mean, all these investment channels that we follow and other people follow, it's all about how to make ourselves richer by studying the company. We want to bring into the equation the discussion, giving back a little bit to, people that are that benefit the most from capitalism and the investing, the public markets, which I think is one of the wonders of the world. So if we benefit from it, there should be some thoughts to giving something back to the community as well. That in my mind, for me, I call it merciful capitalism. Someone else tried to tell us it was, what was the term? Apologetic capitalism. I think of it as
yeah.
I think of it
we're
as
talking with like a hardcore libertarian, and hey, I've got some libertarian tendencies too, but this guy was like very aggressive, just like, oh no, like you guys you need to stop apologizing for capitalism.
Goodness.
We support capitalism. We're capitalists.
Not apologizing. Yeah. So anyway, great. Yeah, it's great chatting with you guys. Thanks for coming on, and we'll see how things go.
Thank you so much. I learned so much from this conversation, so I really appreciate both you guys sharing your knowledge, your experiences, your wisdom with us, and I'm sure a lot of our viewers will get a lot out of it as well.
Yeah, no,
glad to hear it.
Really
Thanks for having
appreciate
us, and I
you
enjoyed
guys having us.
Good, and we'll put all your contact info, your Twitter handles, and YouTube channels and such in the description for anyone who wants to check in on you guys further. Thanks a lot.
Already a much larger EV manufacturer.